All right, I have a quick thing on just enough asset inventory or how to justify your Splunk implementation. There's a lot of Splunk hate in here, and I'm here to help alleviate some of that. The credit goes to this article that I read a while back. They gave me the idea for how to do this in Splunk. So here's my thesis. Your asset inventory sucks. Probably. My asset inventory sucks. I have no idea. I can't get from IT what my asset inventory is. It's done manually by hand, which means that there's errors, and we've checked it. There's tons of errors. There's a single source of truth for your enterprise is really hard to come by, and there's a such thing as operational truth and such thing as organizational truth. Organizational truth is that database where you buy an asset, you scan its serial number in, and then it's in a database forever, and good luck seeing if it gets updated in time. And then there's operational truth, and that's what's actually on your network at any given time, and that's the stuff that you care about when you're doing an investigation. How many people in here can tell me what username had what IP address a month ago? Yes, awesome. So because IT, I have a problem with getting all this information from them, I said, fuck it, I'll do it myself with Splunk. I started with a very strict common information model. I get a lot of log data. I'm a log forensics guy. I get a lot of log data in, and I wanted to figure out how to use it. Getting log data is easy. Using log data is hard because it's not very well usable with one another. Building a common information model helps it, but everyone hates the word common information model, so I made it really simple. I just really care about 4 things, and then anything else I want to add to it. Primary information is the keys to my table, FQDN and MAC address. Secondary information is username and IP address, which is cool, but I can't really do any transforms off that yet. And tertiary information is just additional information that helps me build out context. But what do I store? Live data. Anything that represents that a system or user is live on your network right now. So that's when they get an IP address, when they authenticate to Radius, when they authenticate to a VPN. That indicates that system is now on your network and doing stuff on your network. Historical data is when you plug it into anything that just says this system's been on your network at any point in time. So that'd be JAMP. That would be Active Directory. But what information's where? Well, in my environment, I have it really easy because I have 802.1x, I've got Active Directory, and those sources give me a lot of information that allows me to build this database out. But what's important is that it's not that you have the data, it's what story that data tells you. Radius logs are great, but what does that Radius log tell you? In my case, that Radius log tells me that someone's authenticating with either a wireless AP or a network switch. They have a certificate on that box, and that certificate is tied to a host name, and that host name has a MAC address. So from those logs, I can get MAC address, username, and Wi-Fi IP. Wi-Fi IP is awesome because if you've named your Wi-Fi IP in your Radius with where that AP is, that tells you where in the building that person is at, which is really cool. DHCP, as soon as they authenticate to Radius, most of the people get a DHCP IP address, which gives me MAC address, FQDN, and IP address. If I combine these two, I get a username and IP address. But there's more. Kerberos indicates authentication even between machines. In Active Directory, as soon as your computer identifies it's on an Active Directory, it does a Kerberos lookup for group policy, which is TGS. TGS includes FQDN and IP. And then Windows authentication, well, I'll skip that. But what does the summary search look like? I think Splunk searches look like poetry. So to me, this is poetry. This is basically Kerberos. This is the event ID for someone successfully connected to your network. A calling station identifier is the AP that identified or tried to authenticate that person. Account name, this is me just transforming the username into my common information model, and that's what the table looks like. Wi-Fi AP, hey look, floor 9 AP6. Where's that person sitting at? What's cool with 802.1x, when you walk throughout the building, you renegotiate with every Wi-Fi AP you get near, which means I knew one of these, which means when someone moves through your building, you get to watch them. Anyway, that gets creepy really quick. And now for the moment I've all been waiting for. 3 reasons to justify Splunk. Summary databases do not count against your license cap. You can put anything in a summary database. Anything you have data in your thing and you want to make more data out of it, it won't cost against you. Lookup tables and save searches. You can do lookup tables in Elasticsearch, but you don't think you can do them dynamically easily. I can build dynamic lookup tables based upon information I already have in Splunk and have that regenerate every day. For instance, I plug my entire Active Directory into Splunk. Every day, I call that into a lookup table of every user that's in Active Directory, so I can do lookups based upon username or email address across all of my logs. Save searches, other things have save searches, but I can show you how to use them here. And the transaction command. This needs its own slide. The transaction command is awesome in that it mushes a bunch of data together based upon time and information that you tell it to mush it together. For instance, if you have event A that happens first, then event 2 that happens second, and then event 3 that happens third, because you are saying host and cookie are similar information and they occurred in this order, transaction will mush them together and add all their fields to that one event. So if we go back to the data sources we've got, Radius has, MAC address and username, and DHCP had MAC address and IP address. The transaction command will mush all those together so that now I have username mixed with IP address. Demo time, but I'm not actually going to demo this because I had to do this nonsense. This is what it looks like. It's a raw table. It's not all that interesting. These are all individual events. This is a Windows auth event, so this is someone physically logging into a machine. This is someone using Radius. These do not, oh, look, MAC address. Oh, all right, moving on. This is a munged transaction, so using the transaction command saying, I want all transactions within 8 hours mixed together, and I want to mix them together based on FQDN, MAC address, and IP address, and you get one search that has all of that information mixed together. So you have username, you have IP address, and you have FQDN all in one entry. Putting it to use, this is me. This is my computer. I created a save search called whois that does Splunk poetry. And all I have to do is query my name, and it gives me, here's my computer name, there's my MAC address, here's the last time that I checked in, and here's all my particulars. So now if I'm looking up an incident, I have a throat to choke. What did I do? I took in a lot of log data, created a summary index, put a common information model on it, waited for 30 days. You don't have to wait for 30 days. Splunk allows you to run your summary reports over all your historical data. But I didn't want to do that because it was expensive. So I waited for 30 days, output that summary table. So you take that table that I showed you earlier and you output it to a lookup table every day. And you have an updated asset inventory list of everyone who's been on your network for the last 30 days, 60 days, 90 days. Everything cycles out as they get old. One of the cool things is when you build that transaction off 8 hours and you build that over 30 days, you will see when people change MAC addresses. You will see when people change host names. You will see when multiple users log into the same system. If you know who your admins are, you can see where systems admins are logged into and then build alerts off that. You can, if you're interested in machines that have many, many MAC addresses for some dumb reason, that'll show up plain as day. Generate save searches, speed up adoption, and profit, and that's it. Yeah. Mm-hmm. Correct. Mm-hmm. Yep. Yep. You could even do it a little bit easier than that. If you've got the NetFlow data, then you've got the database port. So you can identify a database server by the number of just the sheer number of connections to a database port. True, but then you can, if you take a longitudinal view of it, there's going to be, a database server is going to have several thousands or millions of connections, whether they're successful or not, internally. And this is internally. I'm not playing on the internet. That's not my playground. But internally, it's going to look like, I mean, you could do based upon established connections, but you could also not and probably get the same information. If you are in a Windows environment, all Windows machines talk to other Windows machines the same way, especially they talk to domain controllers exactly the same way. It's a LDAP lookup, it's a ADDS lookup, then it's a Kerberos ticket, and you can fingerprint different types of Windows machines that way. You can build, what I'm trying to do next is I want to build this exact same thing, but for users. I have ideas on how users execute programs on their computers, and then because I have users tied to the asset table, and I will also have IP addresses mapping connections between different IP addresses, and because I have IP addresses attached to computer names, I now have computer names executing X behavior with this username, and I can start building anomaly detection off that.